Hi guys. Today we're moving on to the second section of chapter 8, multiplying polynomials. This is what the majority of the chapter is going to be on, multiplying two polynomials together. We're going to start relatively easy today. One of our polynomials today is always going to be a monomial, just one term, and then the other polynomial could be different sizes. Before we do that, I want to make sure that you guys remember our rules for exponents. This is from chapter 7, the chapter that we had finished right before we took our finals. We made that secret compartment too, with all the rules in it, so you can always use that if you need to refresh your memory. Mostly, I want to make sure that we understand the difference between these two problems. So when I have two separate variables, they're both the letter x, so they're not different, but they're written separately, that are being multiplied together, we treat that differently than when we have just a single letter x with a power on it, with the two powers on it. Okay, so the first one, the one on the left, x squared times x to the third, that one is an adding problem. We're going to add together the 2 and the 3. So even though it says multiplying, we're not multiplying our exponents, we're adding our exponents. And then for the second one, which is a power to a power, so x squared to the third, that one is actually a multiplication problem. So remember that the math that you do on an exponent is different than the math that you would do on a base. And so, that one is 2 plus 3, which is 5, and then the other one is 2 times 3, which is 6. So you get very, very different answers. So you just want to make sure that you're using the right rules for exponents when they apply. And then the last thing that I want to remind you of before we start our new stuff for today is that if you have our two bases, they're both a letter x, so that's important, and they have different exponents, and we're adding them together. So this looks very similar to that first one on the left-hand side, but instead of multiplying, we're adding. We can't actually do anything with this problem. These are not like terms, so we cannot add them together. So since the exponents are different on the letter x's, we can't do any adding on this one. So these are the three main points that you need to remember to be successful in this chapter. So when you're doing multiplying, you add the exponents. If it's a power to a power, you multiply the exponents. And if it's an addition problem and your exponents are different, you can't do anything with them. And if the exponents were the same, you still wouldn't do anything with the actual exponents. We'll talk about that in a second. All right, let's start with some actual math problems that we're supposed to do for today. So here's our first example. On the outside in front of the parentheses, I have a monomial, 6rs. That's all considered one thing since there's no adding or subtracting in it. And then on the inside, I have a trinomial, 3 terms, r squared s, and then minus 3r, and then plus 2r squared s. Okay. Now in this problem, we are going to distribute. Distributing is something that we learned all the way back in September. This is a little bit different because there's going to be lots of variables, lots of exponents, so a little bit trickier than our initial distributing, but the concept is the same. So we're going to take the monomial on the outside, 6rs, right? And that's considered one thing. And we're going to multiply it by each term on the inside. Now there are 3 terms on the inside of this one, so you don't want to over distribute. Make sure you're only multiplying each term once. So I'm going to multiply it times the r squared s. And then I'm going to multiply it by the 3r. And then I'm going to multiply it by the 2r squared s. Okay? So you want to make sure that you're multiplying each term once by that outside monomial. You're going to treat this as 3 separate multiplication problems. And we are just focusing on the multiplying right now. We're not looking at the adding or subtracting yet. So looking at just the multiplication part, I'm going to multiply the 6rs times the r squared s. And we're multiplying the large numbers, and we're adding the exponents on the same variables. So this is technically 6 times 1, which is just 6. This is r to the first and r squared. That's going to become an r to the third. And then this is s to the first and s to the first, so that will become an s squared. Okay, so that's this right here. On my next one, I multiplied the -6 and the 3, and I got -18. And then I had r to the first and r to the first. That's where this r squared came from. And then in this part, I only had one letter s, so that stayed a letter s. And then finally, I did the 6 times the 2 is 12. R to the first and r squared is r to the third. And then s to the first and s So the first is s squared. Okay, so that was 3 separate multiplication problems. We multiply the coefficients and we add the exponents. And that's a review from chapter 7. Finally, the last thing you should do is you should check for like terms to see if there's anything that you can combine together. Like terms have to have the same variables with the same exponents. So even though all of these have an r and an s, 2 of them have the same exponents on the r and the s. So those 2 we can combine together. When you're combining like terms, you're actually doing an adding problem. So when you're doing an adding problem, you only add the coefficients. You do not do anything with the exponents. So you're just saying, I have 6 r to the third s squares, and I have 12 r to the third s squares. So in total, I have 18 r to the third s squares. So notice that the exponents did not change. I only added the coefficients. 6 plus 12 is 18. And then this, I could not do anything else with that, so I just leave it at the end. And this is my final answer for this problem. So don't get confused. When you're distributing, you're doing a multiplying problem. And when you're combining like terms, you're doing an adding problem. And those have different rules. Why don't you guys try a couple on your own? So go ahead and feel free to pause the video. Try these 3 on your own. When you're ready to check your answers, unpause and we'll see how you did. All right, hopefully you've already finished these problems and we're gonna check our answers right now. So the first one's a pretty basic one. There was not any like variables on the outside monomial, so it makes it a little bit easier. So here's what I got for the first one, 20x plus 35y. So just the 5 times the 4 and the 5 times the 7, and then the variables stayed the same. For the second one, it got a little bit trickier because there were some variables. So make sure when you do x times x, you add the 1 and the 1 and you get x squared. And then don't forget, -6 times -4 is positive 24. When your variables are different, you just put them right next to each other. And, we usually put them in alphabetical order. All right, we're going to try something different for that last one. So I'm going to try to put a question on this video, and then you're going to choose the correct answer, and that will finish our first video for today.